This is SpaceTime, Series 20, Episode 42. Coming up on SpaceTime, history as astronomers see the birth of a black hole. New Zealand launches a new rocket into space, and we turn our eyes to the skies for June's Skywatch. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
For the first time in history, astronomers have watched as a massive dying star collapsed and was reborn as a black hole. The progenitor star, which was some 25 times as massive as the Sun, should have exploded as a bright core collapse or Type II supernova. Instead, it went out with a whisper rather than a scream, fizzling out and leaving behind a stellar mass black hole. The findings, reported in the monthly notices of the Royal Astronomical Society, could explain why astronomers rarely see supernovae exploding out of the death of the most massive stars. It seems as many as 30% of such stars may quietly collapse into black holes without erupting as a supernova. One of the study's authors, Professor Christopher Kokenek from Ohio State University, says the typical view is that a star can only form a black hole after first going through its supernova. However, it now seems a star can fall short of the supernova explosion, yet still form a black hole. That would help explain why astronomers don't see supernovae from the most massive stars. The authors made their discovery while observing a distant spiral galaxy some 22 million light-years away, known as NGC 6946. Nicknamed the Fireworks Galaxy specifically because supernovae frequently happen there, Kokenek and colleagues were watching a star named N6946bh1, which had begun to slowly brighten back in 2009. The problem is, instead of exploding as a powerful supernovae, briefly outshining the entire galaxy, by 2015 BH1 simply appeared to have winked out of existence. The authors used the Large Binocular Telescope, combined with NASA's Hubble and Spitzer Earth-orbiting space telescopes, to search for remnants of the vanquished star, only to find that it had disappeared out of sight. After the Large Binocular Telescope survey for failed supernovas turned up the star, astronomers aimed both Hubble and Spitzer to see if it was still there but merely dimmed. They also used Spitzer to search for any infrared radiation emitting from that location. That would have been a sign that the star was still present but just hidden behind thick clouds of dust and gas. However, all the tests came up negative. The star was simply no longer there. Through a careful process of elimination, the authors concluded that BH1 must have become a black hole. Astronomers say it's still far too early in the study to know for sure how often stars experience these sort of massive supernova non-events. At this stage, BH1 remains the only likely failed supernova found in 7 years of survey work. During the same period, 6 normal supernovae were detected within the galaxies being monitored. Now, technically, that extrapolates to between 10 and 30% of massive stars dying as failed supernovae. This fraction would explain the very problem which motivated the survey in the first place. Namely, that there are far fewer observed supernovae than should be occurring, that is, if all massive stars die through supernova events. The detection also has implications for the origins of large stellar mass black holes, such as those discovered through the recent detection of gravitational waves from merging black holes by the Advanced LIGO Experimental Laser Interferometer Gravitational Wave Observatory. Astronomers say it simply does not make sense for massive stars to undergo supernovae, a process which entails blowing off much of a star's outer layers and yet still have enough mass left over to form a black hole on the scales of those detected by LIGO, which were all around 30 solar masses. The bottom line is it really would be easier to make extremely massive stellar mass black holes if there were no supernova involved. This is SpaceTime. I'm Stuart Gary. New Zealand has joined the space race. It's just hosted the maiden flight of the new Electron rocket. However, things didn't quite go according to plan for the inaugural mission, with the launch vehicle failing to reach orbit. The flight had already been delayed twice due to bad weather. Mission managers claim the launch vehicle's first and second stages both performed nominally, with both ignition and stage separation occurring for each section as planned. They say the payload fairing separation also went smoothly, and so are still sifting through the telemetry data in order to determine the cause of the anomaly. The Electron rocket is being developed in New Zealand by the American company Rocket Lab. The 17-metre tall two-stage carbon composite launch vehicle was both designed and manufactured in New Zealand. It's capable of carrying a small 150-kilogram payload into a 500-kilometre high low Earth orbit. The Electron's first stage uses a cluster of 9 Rutherford electric engines burning rocket-grade RP1 kerosene and liquid oxygen oxidizer for 300 seconds. The engines are mostly 3D printed, and they use electric rather than traditional high-pressure gas turbopumps. The Electron's upper stage uses just a single Rutherford electric engine, burning for 327 seconds. The Electron flies from a newly built launch complex on the Mahia Peninsula on the North Island's east coast. The facility includes both a vehicle assembly building and launch pad, and is designed to handle up to 120 launches a year at a rate of 1 every 72 hours. Mission control is based some 500 kilometres away in the New Zealand city of Auckland. The Electron follows on from Rocket Lab's suborbital 20-metre tall Atea-1 sounding rocket prototype. It flew once in 2009. Rocket Lab's targeting the Electron at the small payload end of the market, with launch costs under $5 million a flight. Currently, small satellites and CubeSats are forced to ride piggyback on larger missions using full-scale rockets such as the Atlas V, Falcon 9 and Delta IV. Rocket Lab claim they already have several customers signed up, including NASA, and are expecting a busy 2018. I'm Stuart Gary. You're listening to SpaceTime. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and junk on the web I find interesting, important, or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter. And on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. And now let's turn our eyes to the skies and check out the month of June on Skywatch. June, the 4th month of the old Roman calendar, is named after Julius Caesar. Of course, June also marks the Winter Solstice in the Southern Hemisphere, which this year happens at 14:24 Australian Eastern Standard Time on the afternoon of June the 21st. That's 4:24 AM Greenwich Mean Time. And of course, while it means winter is well and truly here south of the equator, for our lucky listeners in the Northern Hemisphere, it means the start of summer. The June solstice occurs when the sun reaches its most northerly point in the sky as seen from Earth, zenith appearing to be directly over the Tropic of Cancer. Of course, the seasons are governed by the tilt of the Earth's axis as it journeys around the sun every year. On the day of the June solstice, the Earth's south pole is tilted by 23.5 degrees away from the sun, and the north pole by 23.5 degrees towards the sun. It means the sun will rise north of east and set north of west. When it's the south pole tilted towards the sun and the north pole tilted away, it means it's the southern hemisphere's summer, but that won't happen till December. 6 months later, like now, when the south pole's tilted away from the sun, it's winter time. Of course, in between, we have the autumn and spring equinox. Temperatures on Earth aren't determined by Earth's orbital distance from the sun, but rather by the angle of the sun's rays striking the Earth. In summertime, the sun is high in the sky, and the rays hit the Earth at a steep angle. In winter, the sun is lower in the sky and the rays strike the planet at a more shallow angle. In most parts of the world, the seasons begin on the day of the solstice or equinox. However, Australia's always been a bit weird that way. Here, for some reason, seasons begin on the first day of a particular calendar month. In March, it's for autumn, June for winter, September for spring, and the 1st of December for summer. Well, almost directly overhead this time of year, we have the magnificent constellation Virgo. Virgo was the goddess of justice and also the goddess of the harvest in ancient Greek mythology, using her scales to weigh good and evil. However, she became disenchanted with the evil deeds of men. So she threw away her scales and retreated to the heavens. Now, I mentioned that as well as justice, Virgo was also the goddess of harvests in ancient Greek mythology. And that's interesting because the ancient Egyptians also associated Virgo with agriculture. There she was the goddess Isis, who would sprinkle heads of wheat across the sky, forming the Milky Way. To science, Virgo is a tightly packed region of space containing some 2,000 galaxies, gravitationally bound into a giant galaxy cluster located some 60 million light-years away. Our local galaxy group is an outlying member of the Virgo cluster. The Virgo cluster forms the heart of the Virgo supercluster, one of the largest known structures in the universe, a massive galactic node in the large-scale cosmic web-like structure of the universe. In fact, the mass of the Virgo supercluster is so great that its gravity generates the Virgo-centric flow, causing our Milky Way galaxy, as well as Andromeda and all the other members of the local galactic group, to move towards the supercluster at some 400 kilometers per second. And that's despite the accelerated expansion of the universe over cosmic timescales, causing galaxies to move away from each other. As big as the Virgo supercluster is, it's now thought to be just a lobe of an even bigger galaxy supercluster called Laniakea, the centre of which is known as the Great Attractor. Despite its size, the Virgo cluster is so far away it's actually hard to see without a decent-sized backyard telescope. In fact, you'd need something at least 100 millimeters in diameter or larger. Also directly overhead is the constellation Corvus the Crow. Greek mythology tells us Corvus could talk to humans but was a lazy bird, and so Apollo took away his ability to speak and banished him to the heavens. One of the highlights in the constellations Virgo and Corvus is the spectacular Sombrero galaxy, M104. Visible with a good pair of binoculars or a small telescope, this stunning spiral galaxy is seen almost edge-on, providing a spectacular view of its galactic bold stars and the molecular gas and dust lanes in its arms. M104 is located some 31 million light-years away and is moving away from the Milky Way at about 1,000 kilometers per second. The Sombrero galaxy has a diameter of about 50,000 light-years, about 30% the size of the Milky Way. It's surrounded by some 2,000 globular clusters, tight balls comprising millions of stars, and there's an active central supermassive black hole, at least 1 billion times the mass of our Sun. Now, by comparison, Sagittarius A star, the supermassive black hole at the centre of our own Milky Way galaxy, is just 4.3 million times the mass of the Sun. The brightest star in Virgo is Spica, a spectroscopic binary located some 250 light-years away. Spectroscopic binaries are pairs of stars orbiting too close to each other to be separated by telescopes, and so can only be distinguished by the Doppler shift they display in their spectral signature, showing that there are two stars present. The two stars in Spica are very close together. In fact, they orbit each other every 4 days. Being so close, their gravitational interaction has caused them to become rotating ellipsoidal variables. That's astrophysics speak for egg-shaped. The primary star is a variable blue-white giant. It's about 10 times the mass of the Sun, and at least 7.5 times the Sun's diameter. Once a spectral type B main sequence star, it now has some 12,100 times the Sun's luminosity. The giant star is now both pulsating rapidly and also rotating at more than 199 kilometers per second over a 0.1738 Earth day period. It's one of the nearest stars to Earth, expected to end its life as a core collapse or type 2 supernova. The second star in Spica is also thought to be a spectral type B blue-white giant. It's somewhat smaller, with about 7 times the Sun's mass and some 3.6 times its diameter. Now, if you look above the western horizon in the early evening, you'll see the fourth brightest celestial object in the night sky, the dog star Sirius. In fact, only the Sun, Moon and planet Venus look brighter. Sirius is a binary or double star system, and it's located relatively nearby, just 8.6 light-years away in the constellation Canis Major, or the Greater Dog. The primary star, Sirius A, is a hot spectral type A white star, at least twice the mass and size of the Sun, and about 25 times more luminous. It's orbited by Sirius B, a faint white dwarf. The system's thought to be between 200 and 300 million years old, and Sirius B is thought to have become a white dwarf about 120 million years ago. White dwarfs are the stellar corpses of Sun-like stars. After having used up its nuclear fuel supply, fusing hydrogen into helium in the core, it expands into a red giant as it begins the core fusion of helium into carbon and oxygen. The problem is Sun-like stars aren't massive enough to fuse carbon and oxygen into heavier elements, and so once they've used up all their core helium, they turn off. Their outer gaseous envelopes float off into space as spectacular colourful objects known as planetary nebula. What's left behind is the super-dense white-hot stellar core, about the size of the Earth, known as a white dwarf, which will slowly cool down over the eons of time. Ancient Egyptians used Sirius to determine the annual flooding of the River Nile. And amazingly, they are also able to use it to determine the exact length of a year to within 11 minutes. The two stellar companions, Sirius A and B, orbit each other at a distance ranging from 8.2 to 31.5 astronomical units. An astronomical unit is the average distance between the Sun and the Earth, about 150 million kilometres or 8.2 light minutes. Sirius is gradually moving closer to the solar system, and so over the next 60,000 years or so it will steadily increase in brightness. However, in about 60,000 years' time, the binary will begin moving away again, and it will gradually become fainter and fainter, but it will continue to be the brightest star in Earth's night sky for at least the next 210,000 years. Looking to the northwest, that is to the right of Sirius, you'll find another fairly bright star, called Procyon. It's the brightest star in Canis Minor, or the Lesser Dog. In Greek mythology, Canis Major and Canis Minor were Orion's hunting dogs. Located some 11.6 light-years away, Procyon is another double-star system, comprising a spectral type F white-yellow star Procyon A and a faint white dwarf star Procyon B. Procyon A is about 50% more massive than the Sun and has about twice the Sun's radius. It's unusually bright for its mass. That suggests that it's evolving into a subgiant that's fused nearly all of its core hydrogen into helium and will soon expand into a red giant within the next 100 million years or so, in the process increasing its diameter by up to 150 times its current size. The white dwarf Procyon B is about 0.6 times the mass of the Sun and has a diameter of about 8,600 kilometres. The pair orbit each other every 41 years at an average distance of about 15 astronomical units. That's about the same distance as Uranus is from the Sun. Turning further to the right and looking to the north-northwest, you'll see the constellation Leo the Lion, looking like a bunch of stars shaped like an upside-down question mark. The brightest star visible in Leo is Alpha Leonis, or Regulus, the Little King, located some 79 light-years away. Regulus is a multiple star system, comprising of at least 4 stars. Regulus A is another spectroscopic binary, consisting of a rapidly spinning spectral type B blue-white star about 3.5 times more massive than the Sun, and a small companion, probably a white dwarf. They take about 40 days to orbit each other. The primary star completes a full rotation in under 16 hours. That compares to our Sun's 30-day rotational period. Spinning so rapidly gives the primary star a very oblate appearance and causes gravity darkening, meaning its poles are considerably hotter and at least 5 times brighter per unit surface area than its equatorial region. Astronomers have calculated that were it rotating only about 15% faster than it is, the star's gravity would be insufficient to hold it together, and it would literally fling itself apart. Located further away than Regulus A are Regulus B, C and D, which are all dim main sequence stars. Regulus B and C are thought to orbit each other about every 600 Earth years, and they're located some 5,000 astronomical units from Regulus A. Regulus B is a spectral type F white-yellow star, while its companion Regulus C is a small spectral type M red dwarf star. Regulus D is a dim star which appears to share motion across the sky with others in the group. The constellation Leo was mentioned by Homer in his famous 8th century BCE poem, The Odyssey. About 25 degrees above the north-northeast horizon this time of year, you'll find the bright star Arcturus, the brightest star in the constellation Bootes, the herdsman or ploughman. Arcturus is the 4th brightest star in the night sky. Located just 36.7 light-years away, Arcturus is a bloated aging red giant, about 7.1 billion years old. Having used up all its core hydrogen, it's dropped off the main sequence and is now fusing helium into carbon and oxygen. This has caused the star, which is only slightly more massive than the Sun, to expand out to about 25 times the Sun's diameter, in the process becoming some 170 times as luminous. In Greek mythology, Arcturus was the guardian of the bear, being next to the constellations Ursa Major and Ursa Minor, the greater and lesser bears. There are some indications that Arcturus could have a binary stellar companion, but the results remain inconclusive. There's also speculation that it could have a large planet or substellar object of about 12 Jupiter masses orbiting it. Now that's close to brown dwarf size, but again the research remains inconclusive. Okay, that's the north, let's turn east now. And the 3 brightest stars in the constellation Libra, Scales of Justice, are visible almost halfway, about 40 degrees above the horizon. These stars represent the claws of Scorpius the Scorpion, which according to Greek mythology is chasing Orion the Hunter across the sky. The brightest star in the constellation Scorpius is Alpha Scorpii, or Antares, and marks the scorpion's heart. In ancient Greek, Antares' name means the rival of Mars, the god of war, because its golden-orange appearance is similar to that of the red planet, and also it appears to pass very close to Mars every 780 days. I say appears to pass very close to Mars because in reality Antares is some 550 light-years away. It's easily seen with the unaided eye because it's one of the largest known stars in the universe. It's a red supergiant, about 18 times the mass and a huge 883 times the diameter of the Sun. In fact, were it placed where the Sun is in our solar system, Antares would engulf all the terrestrial planets, Mercury, Venus, Earth and Mars, and its visible surface would extend almost as far out as the orbit of Jupiter. Astronomers think Antares began its life some 12 million years ago as a spectral type O or B blue star, about 17 times the mass of the Sun. At the moment, Antares is about 10,000 times more luminous than the Sun. Like the similarly sized red giant Betelgeuse in the constellation Orion, Antares will almost certainly end its life as a spectacular Type II or core collapse supernova, probably fairly soon, at least within the next 100,000 years or so, which, by the way, is relatively soon in astronomical terms. When it does finally explode, the Antares supernova should be as bright as the full moon for several months and be clearly visible in daytime. Just before we leave Antares, it's worth mentioning it has a companion star, Antares B, which is located between 224 and 529 astronomical units away from the primary star. Now, right next to Antares, we see the globular cluster M4. Easily seen through a small pair of binoculars, the M4 globular cluster is located some 7,200 light-years away. It's a tightly packed ball made up of a million or so stars. As with all globular clusters, the stars in M4 were all originally born at the same time in the same molecular gas and dust cloud, some 12 billion years ago. There are two other interesting stellar clusters in Scorpius, M6 and M7. But unlike M4, these are both relatively young open clusters. Like globular clusters, open clusters are groups of stars which all originally formed at the same time and in the same stellar nursery. But unlike globular clusters, open clusters are usually much younger. They contain far fewer stars and are far more loosely gravitationally bound, so eventually they dissipate as their stars gradually move away from each other. M6, or the butterfly cluster, is about 1,600 light-years away and about 12 light-years across. It contains about 80 major stars, all of which are less than 100 million years old, again very young in cosmic terms. At 200 million years, M7, or the Ptolemy cluster, is about twice as old. First noted by Greek astronomer and mathematician Claudius Ptolemy, it can be easily seen from dark locations with the unaided eye. It's about 980 light-years away, about 25 light-years wide, and also contains about 80 stars. Okay, let's turn to the southeast now, and you'll see the constellation Sagittarius the Archer. To the ancient Babylonians, Sagittarius was the god Nergal, a centaur, a creature half man and half horse. By the time Greek mythology took over, Sagittarius was carrying his bow loaded with an arrow pointing directly towards Antares at the heart of Scorpius the Scorpion. In science, Sagittarius points to the direction of the centre of our Milky Way galaxy, and located some 26,000 light-years away is our galaxy's central supermassive black hole, Sagittarius A star. Looking directly south now, we see the star Polaris Australis, or to be more accurate, Sigma Octantis. It's the nearest star to the southern celestial pole, and consequently the counterpart to the North Star Polaris. However, Sigma Octantis is far harder to see than Polaris because it's much fainter. Located some 270 light-years away, it's an orange giant nearing the end of its life. Turning to the southwest and just above the horizon, we find Canopus, the second brightest star in the night sky after Sirius. It's located some 310 light-years away, and is the brightest star in the constellation Carina the Keel. Canopus is a supergiant, some 9 times the mass of the Sun, with at least 71 times the Sun's diameter. It's over 10,000 times more luminous than the Sun, and it's a strong X-ray source, probably generated by its corona, which is magnetically heated to several million degrees, and stimulated by the star's fast rotation and strong internal convection currents percolating through its outer layers. Jonathan Alley, the editor of Australian Sky and Telescope magazine, is back, and he joins us now for the rest of our tour of the June night skies. It's a great time to look up at the night skies and marvel at the majesty of the Milky Way as it puts on a spectacular overhead display.
If you go out in the sort of 8 o'clock, 9 o'clock, the Milky Way is stretching from east to west right across the sky. Now, if you live in a city, you're probably not going to see it. If you live in the country, you'll see it. The beautiful expanse of the Milky Way going from east to west, it's just really glorious. The darker spot you can find, you can pick it up much, much better, even if you are in the city. If you can find somewhere where there are not too many lights around or you're sheltered from the lights, have a go. You might be able to see, well, you'll certainly see lots of stars, but you might not pick out the faint milkiness of the entire galaxy as it spans from horizon to horizon. But nevertheless, planet-wise, the evening is dominated at the moment by the king of the planets, Jupiter, which for stargazers in Australia and other southern latitudes is almost overhead around about 8 p.m, nice and high, so you really can't miss it. The planet Saturn can be seen too, down lower in the east. For those at northern latitudes, our friends up in the north, Jupiter is in the southern half of the sky. You still won't be able to miss it because it's really bright. And Saturn is low down in the east, a bit lower down there. Now, if you can't figure out which dot of light is Jupiter, don't worry. Go out and have a look on June the 4th because the moon will be right next to it. Okay, so you won't be able to miss it. Just look for the moon and there'll be a bright star-looking thing very close by. Well, that's actually the planet Jupiter. And if you miss it on June the 4th because of, whatever, the weather or something, have a look 4 weeks later on July the 1st because the moon will be even closer, right up close next to Jupiter. Now, of course, that's just a line of sight effect. In space, they're a long way apart. The moon's only a few 100,000 kilometres from us, whereas Jupiter's hundreds of millions of kilometres from it. But it doesn't look like that in the sky. It looks like they're right next to each other. And anyway, Jupiter, as I say, is pretty easy to spot as it's brighter than all the other stars around it up there at the moment. So that's a really good way to find planets. If you're having trouble identifying which planet is which, or is that a planet or is that a star? Because as the moon does its orbit around the Earth, it passes by each of the planets, with the planets being in the background, of course.
And this is all because they form pretty well along what we call the ecliptic.
Yeah, it's the plane of all the planets. If you looked at the solar system from the side, then all the planets are sort of in a line. They're not way up above the sun and way down below. They're all sort of left to right in a line or a plane. So they all sort of seem to be roughly on the same line in the sky. The moon's a little bit askew to that, but it passes pretty close. So it will be passing right next to Saturn too, as well as Jupiter. Saturn, if you go out on the 9th or 10th of June, you'll be able to see Saturn next to the moon. Again, you can't really miss it because Saturn's pretty bright. And if you know someone who has a telescope, for goodness sake, ask them for a peek at Saturn. You will not be disappointed because it just looks amazing with its rings and everything, and you'll probably see 1 or 2 moons as well. Now, if you're an early riser rather than a night owl, the morning sky at the moment is dominated by Venus. Really, really bright, shining out there in the eastern sky, or northeastern from the southern hemisphere and sort of southeastern from the northern hemisphere in the hours before dawn. You cannot miss Venus because it is so big and bright. Only the moon and the sun are ever bigger and brighter than Venus. Well, they're always bigger and brighter, but Venus, you just can't miss it. At the moment, it's called the morning star, but sometimes it appears in the evening skies out to the west, which times is called the evening star. But at the moment, it's the morning. Mercury, the innermost planet, is sort of disappeared below our horizon now, so you can sometimes see that in the morning and evenings as well. This time of year, unfortunately, no, we can't. And the other planet that's normally visible, Mars, it can't be seen at the moment either because it's around the other side of the sun from us, so it's lost in the solar glare, and it won't be back in view in our skies until September. Now, just finally, for our listeners in North America, I hope you're starting to get excited because in just a little more than 2 months from now, you're going to be in for a real treat because you're going to experience a total eclipse of the sun. It's been ages since there was a total eclipse of the sun seen from the US mainland, not since 1979, in fact. Would you believe it? The last eclipse that was seen from any part of the United States was in 1991, and that was from just a small part of Hawaii. So no one on the mainland of the United States has seen a solar eclipse unless they've travelled somewhere else in the world to go and spot one. So this is going to be pretty specky. So this is
the
going
lower
to take
48,
place,
we call it.
The lower 48. Well, this eclipse is going to happen on August the 21st, and the path of totality, where you see the sun completely covered up by the moon, will stretch from coast to coast, from one side all the way across to the other, from Oregon all the way over to South Carolina. And if you're along that path of totality, that's where you're going to see the sun covered up by the moon. And I think at maximum it's going to be for about 2.5 minutes. Should be really spectacular. If you're not on that line, that thin path, if you're either side of it, you'll see a partial eclipse. You'll see the moon almost totally cover up the sun. The further away from that line you are, the less and less of the sun gets covered up. So if you're a fair distance away, you'll just see this dark bite out of the solar disk as the moon just moves in front of it. So I say, you'll see, but of course, this is a solar solar eclipse, so like all solar eclipses, you must be very careful not to damage your eyes. There are some special telescopes that you can buy that are set up with proper filters already. They come built into the telescope with their solar telescopes, and you can look at the sun very safely with those. And you can also get those little cardboard spectacles from various places that have got special mylar filters built in where the glass would normally be on a normal pair of spectacles. So you can use those as well. Just make sure you've got good ones and they don't have any scratches or holes or anything in them that can let the sunlight through. But other than that, you do not be tempted to look directly at the sun with or without any kind of optical aid, because you can do yourself some real damage. So things like welder's goggles, exposed film, and all those sort of old urban myths, just forget them, because you can blind yourself basically. Don't risk it. Any doubt, or if you need to know more, you can check out the Sky and Telescope website, because there's stacks of information about this upcoming solar eclipse.
It's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and junk on the web I find interesting, important, or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter. And on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts, or Audio Boom. This has been another quality podcast production from Bytes.com.